1 2 1 2 1 2 1 2. Okay. Which one is that one?
Extra science.
No, the life.
The
Yebo
extra
physics. Yebo physics life.
Oh, you know physics.
It won plus 5 days ago.
5 days ago, I think that was a trial run.
A trial run.
Yeah.
So I should go to. I go to which one? Live.
Units what?
The live one, yeah.
Which one?
This one.
Yes, yes, that's the one. Sound is okay, right? Okay, good. So it's solved.
5
days ago, I think that was a trial run. Introduction. It should show a live icon. Okay, 3 viewers, 2 viewers. It's I think that should be
20 viewers.
this.
Does it have 20 viewers now?
20.
No, I'm asking because there's 2 viewers.
It's 2 here. I can also see 2 here.
I can't see live.
Where's your search?
Yeah, I'm just on search. Where I am now? Here.
Okay, so we'll click type live in front of that. No, it's okay. You can
physics.
continue.
LTE. You know the
The
other one is
network.
full.
Yeah.
Edrom is full.
These three videos, are they for this year?
The 3, yeah.
Oh. You started this year?
We started afresh. You see the viewers. We started.
When I started-
We removed all the old videos.
Oh, every year you remove. Okay.
When are you starting your geography?
They are making a lab for me. They are preparing a lab for
Up.
me. Yeah.
Ah, yes, the live one.
So you are supposed to do that, eh?
To
Or
do
somebody's
or
preparing the lab.
to prepare that one.
Yeah.
I think we'll do it again. I think Friday we have a lot of things to do. Yeah.
Things to do.
So we have to do it on Friday.
Maybe let me email the lady. I forgot to. Let me send her WhatsApp. I forgot to ask what time.
Okay,
is
so we have people connected. I think I'll just go for these 15
Okay.
minutes. All right. Thank you, David.
I'm hoping before I move to
Okay. Hello, guys. Welcome to another session, Yebo Physics. So I'm just gonna look at a few questions for those of you who are doing that's FVV 101. Right, so in the earlier session, we had a challenge with our audio. So we had to try and work out to solve the challenge. And now we'll just look at a few questions. We only have a few minutes though, so I'll just highlight on some questions that we wanted to consider for this part. So these questions are from the physics workbook. From your physics workbook, you have questions in section, I think that's 4.5. Yeah, this is section 4.5. There we are. So if you go to section 4.5 of your physics workbook, you will see this set of questions on standard form, changing standard form to scientific notation, and from scientific notation to standard form, and switching between exponents again. So that's basically what we have for today, but more of the questions that are in the sections that follow, we'll look at them together tomorrow. So we just started this video to just make sure the channel is in order. So I'll just go through at least maybe just a few questions, about 2 questions, and I will do the rest tomorrow. So what we have on question number 1 is convert from standard form to scientific notation, write the following in scientific notation. So we have different numbers. The scientific notation helps us to express numbers which can be very small, or numbers that can be as big as the one at part 1.1 in a very clear and concise manner. So for the first one, let's look at the first number there. So the instructions for this one, are given in the preceding section, which simply describes the methodology or the steps that you need to follow when you are presenting the numbers in the different notations. Okay, so here what we have is this number, seven, 3, 4, with that's 734 billion, right? Okay. So something is not fitting properly there. Let me make it smaller. Seven, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the number given, 734 billion, and we have to express this in scientific notation. So when we're expressing a number in scientific notation, we take the first non-zero digit to be the number which includes the numbers between 0 and 10, or the numbers starting from 1 to 9. So we have that number, and the rest of the numbers that follow after it should come after the comma. So in this case, the number here is 7. So it means we start from the right of that number and count the number of digits until we get to the point where we have our comma. The number of places that we move there will be the power that we include as a power of 10. So in this case, a number like this one should give us 7.34 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the 11, like that. So we express this number by counting the number of decimal places that we have moved, right, from the last digit until we place that comma. So in this case, we have moved to the left, starting from here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and the comma rests there. So when we place our decimal comma there, that means our number, our power of 10 should be 11. So we have 7.34 times 10 to the 11. So that's for part 1.1. So this is a very simple exercise which you can do alone for the rest of the numbers. For part 1.2, which is somewhat a bit different, for part 1.2, we have a number like 0.000015, right? So with this number, we said our first digit should be a non-zero number, or a non-zero numeral, which in this case will be 1. So we're moving our decimal place to the right. remember for the first number, the one on top, we moved it to the left and the power of 10 was positive. So when we move the decimal point to the right, the power of 10 will then be a negative. Such that for this one, we move it 1, 2, 3, 4, 5, and we have 1.5 times 10 to the negative 5. So because we moved our decimal place to the right, our power of 10 will contain a negative number. So we have 1.5 times 10 to the minus 5. So this is how we express our the different numbers given there in scientific notation. Right, so if you're just joining us, we are just doing this run to try and ascertain that we don't have a glitch again tomorrow when we meet for our tutorial. So we had the session run in the afternoon, but for those that were on YouTube, we were not able to rectify for the challenge with the audio. So this is why we are simply running this stream. We were just working on the audio, the technical glitch that we had in the afternoon. But for the recording that we did in the afternoon, please follow the link that has been sent to you via email, via your student emails. That link to the Teams platform, if you check under the chats on that platform, you should see the recording for the afternoon. The recording should be available there. Okay, so before we just call this session off, let's look at the conversion from scientific notation to standard form. So we have a number like 3.15 times 10 to the minus 4. What do we do with such a number? How do we revert back to scientific notation? From scientific notation, to standard form. For a number like 3.15 times 10 to the negative 4. So in this case, because of this negative sign, we said we included this negative sign when we shifted the decimal place to the right. So because of its presence, when we are replacing or taking this form from scientific notation back to standard form, then we have to take the decimal place 4 steps back to the left, right? So in this case, this would mean from 3, if we move 1, 2, 3, 4 steps, the comma, we have 3 zeros before the 3. So this will mean we have 0.000315. So we've shifted from 3, 1, 2, 3, 4 to the left. And this number remains as 0.000315. So it's only an operation where when you have a negative in a negative power of 10, then you replace that you replace that decimal place decimal comma by shifting it that number of steps but to the left. Okay, so the 10 to the minus 4 simply tells you this is a fraction, right? 10 to the minus 4 is 1 over 10 to the 4, so it makes that a fraction. Your number should not be bigger. When you look at it, your number cannot be bigger than what you have initially. So those are some of the things you need to look out for when you do these conversions. Okay, so for 2.3, part 2.3, which simply says, so we have 2.3, we have 6.34 times 10 to the 3. And this time we have a positive power of 10. This time we have a positive power of 10. So with that positive power of 10, what it means is we will shift the decimal point 3 steps to the right. So this is 6.34 with 1, 2, 3, and we place a 0 there. So this decimal place lies there at the end, and what we have is 6,340. So the number there is 6,340. So you can work out more examples there with regards to the physics workbook, but let's make a date again for tomorrow between 12 and 2. We'll be live on this platform and live on Teams. We will do more questions, and if you have any questions regarding measurement and units, I'm sure you have done vectors already. We'll also have examples of those questions. So when you if ever you would have any question regarding what you have come across and you need it addressed, this is the platform. Feel free to ask the question or to just give your contribution. That will also help your colleagues when you raise those questions and you have them answered on the platform where everyone can listen and be assisted. So otherwise, from me and everyone in the studio, it's goodbye. Let's meet again tomorrow.